Hello, hello, hello. So we're going to be going over the chemical reactions review sheet. You hopefully have your purple packet open and you are ready to review balancing reactions. So what are we trying to achieve when we balance reactions? We're trying to show that we have an equal number and type of each atom on both sides of the reaction. A reaction starts with reactants on one side. It finishes with products on the other. And if we take a look at question number 1, we see that the sodiums on this side are 2 and the sodiums on this side are 2. So the sodiums are currently equal. The amount of carbon here, there's a carbon there. And over there, there's one carbon. There's one carbon on each side, so they're equal. There are how many oxygens? Look, there's 3 oxygens there. And then here are 2 oxygens plus 1 oxygen. 2 plus 1, also called 3. So the oxygens are equal. Now wait a minute. Here's oxygen, but that oxygen there is in SO4, and this is also SO4. We call it SO4 what? We call SO4 sulfate. So the oxygens are attached to the sulfur on both sides, and then the last element for number 1 was hydrogen. There were 2, and there were 2, so the hydrogens are already equal. So reaction number 1 was already balanced for us. That was great. It was already balanced for us. And let's go ahead and just point out that the arrow there separates the reactants from the products. Number 2. When we looked at number 2 originally, this number here was not given to us. So let's just kind of block it out for a second, just for fun. There we go. So right now, before that number 2 was put in there, we had 1 calcium, 1 calcium, 1 oxygen, 1 oxygen, 1 hydrogen, and on the other side there were 2 hydrogens, which is why we wrote a 2 right there. When we put this 2 in front, like we did here, let's just do this. We put that 2 right there, that doubles the entire formula. So that's 2 hydrogens and 2 chlorines. The coefficients, like that 2, act as multipliers. They multiply whatever values are there. We're basically saying that there's an HCl and there's another HCl. And that's very poorly written, sorry about that. But there's 2 hydrogens and 2 chlorines. Let's just get rid of that. That evidence needs to go away. There we go. Okay. So by putting that 2 there, we now have 2 chlorines and 2 hydrogens, and we've made it so that both sides of this reaction show the same number of each element. On to number 3. Again, we're trying to balance the reaction. We put a 2 in front of the second compound to double the potassium and the iodine. We put a 2 on the KBr on the product side to make the 2 reactions equal. Number 4, same idea. Number 4, we did have to be careful with the oxygens here. That's 5 plus 1. 5 plus 1 is usually known as 6. Oxygen is probably not the element we were going to start with there, though, because oxygen is in 2 spots. Maybe we start with this nitrogen here instead. There's 2 nitrogens. Over here there was only 1 nitrogen, so we had to multiply that by 2, and that turned out to fix all of the issues. Alright, let's move on. Number 5 was by far the hardest question in the entire worksheet. Not quite as hard as number 14, but still pretty hard. We'll talk about number 14 later. So number 5, we probably start off with the coppers, and coppers are already equal. So which element are we going to do last? When we talked in the notes, we said that oxygen was usually last. This is a good example of why oxygen is last. So on this side, called the reactant side, oxygen only appears this one time. On the product side, though, here's some oxygen, and there's more oxygen. And since oxygen is in a lot of places, it's going to be difficult to tame. It's going to be difficult to balance. It's really just going to be all around difficult to handle. So, don't. At least don't do it yet. Let's move to a different element. Nitrogen. There's nitrogen, here's nitrogen, and here's nitrogen. Again, nitrogen's in too many places. Don't do it yet. Let's pick an element that only appears in two places, one on each side, and it's a simple fix. One hydrogen, two hydrogens. This would have been easily fixed by putting a 2 here and a coefficient of 1 there. That would have made the hydrogens equal. When you did that, though, you would struggle to get the nitrogens equal, but you would have determined that this ratio for the rest of this worksheet, the rest of this question, should be something similar to a 2 to 1. So if 2 to 1 didn't work, maybe you try one of the other types. Eventually I settled on a 4 to 2 ratio, and 4 to 2 is the same as 2 to 1. Once I found the 4 to 2 ratio in there, I was able to fix the nitrogen. Number 6 has one key thing we're going to see a lot. Polyatomic ions. In the left and the right side, we see the polyatomic ion nitrate. Nitrate is NO3 with a -1 charge. The -1 charge isn't showing up here because it's balanced out by the positive charge of the silver and the magnesium. However, the NO3 is present on both sides. It makes it a whole lot easier to balance if we think of this side as NO3 times 2, and then on the other side, that NO3 has to be multiplied by 2 to make the NO3s equal. After doing that, we can fix the silvers and the chlorines at once. Let's go on down to number 8. So number 8, a little bit tricky in one spot, the oxygens. Again, why are we doing the oxygens last? Oxygen appears in 2 compounds on the product side. That's going to make it harder to balance. So maybe I start with the nitrogens. And 1 nitrogen and 1 nitrogen. Those nitrogens are already balanced. I need to start somewhere else. 3 hydrogens, 2 hydrogens. This should be an easy one to start with, because the hydrogens will only appear one time on either side of the reaction. We need to try to find a number that 3 and 2 will both multiply into. That's right, we need to multiply this one by 2 to give us 6, multiply this one by 3 to give us 6. So now we have 2 times 3 and 3 times 2, so they both have 6. When we did that, it messed with the oxygens on the product side, but we still don't want to handle the oxygens yet, because there's still nitrogen to handle. So, what's going on with the nitrogen right there? Before we multiplied it, it was only 1 nitrogen, but now with the 2 in front, it's 2 nitrogens. So we're going to come over here, and we're going to fix this side by multiplying it by 2. So at this point, we have fixed the nitrogen and we have fixed the oxygen. It's time to go ahead and try, I said the wrong thing. We fixed the nitrogen and we fixed the hydrogen. Now it's time to try to fix the oxygen. So what can we do here? Oxygen. We've got 2 oxygen plus 3 more oxygen. That obviously equals 5. On the other side, though, we also need to have 5. Currently we have 2. We need to multiply this by a value that would equal 5. We can't do 2 times 2, because 2 times 2 would be equal to 4. We're going to do 2.5. Now, we're not supposed to have fractions like that. We're not supposed to have 2.5. Technically, this reaction is balanced, but they're all supposed to be whole numbers. So, we need to take a moment and we need to fix that one value so that it's a whole number. And when we do that, we're going to have to fix them all. So in order to fix the 2.5, I had to multiply every value, every coefficient, all of those numbers in front, by 2. I doubled them all up. 2 became 4, 2.5 became 5, 2 became 4, and lastly 3 became 6. Now the reaction's balanced, and we're using whole numbers. So let's look at number 9. What polyatomic ion can you find that's going to make this easier? If you said hydroxide, you're completely wrong. That's not hydroxide, that's sulfate. In fact, the one I just underlined is sulfate times 3. So on the other side, we did sulfate, and we multiplied it by 3. Once we did that, we fixed the hydrogens, and then we fixed the gallium. Hydroxide, so silly. Number 10. At this point, you're probably wondering why I'm talking like this. I just kind of realized all of a sudden I'm using this kind of like weird monotone voice. Sorry about that. I'm not sure where it's coming from. It's just probably because I'm working at home on my laptop and want to make sure that everything I say is coming across clearly. So instead, I'm talking like this. I don't know, it's kind of some sort of weird announcer voice. Okay, anyway, number 10. Number 10's not got too much weird going on in it. The iron, oxygen, carbon. Here we see the oxygen appearing twice, so our instincts would be to try it last. But we easily see that I could fix the iron right there. And then I run into kind of a wall, if you will. I can't get the oxygens right. I had one kid one time say, well, if we just did this, would that fix it? And I kind of puzzled on that, and that doesn't fix it. So this is one of the few questions where we're going to kind of stumble into the answer. So let's go ahead and stumble as a group. We have 2 irons, so I'll put a 2 there. I have 3 oxygens and another oxygen, so 3 and 1. That is hard to read, but that's supposed to be a 3 and a 1. Let's see. 3 plus 1 is obviously 4. So a lot of people hop on this and do a 2. When you do that 2, it messes the value up that goes here because of the carbons. So when they back up, and we're just going to try something different. We just had 1 and 2 here, and that didn't work. So now we're going to try 2 and 2. That's not going to work. And the reason I'm trying these numbers the same is the carbons have to match. Whatever value on one side has to match the other side. So let's try, since 1 and 1 aren't working, let's try 3 and 3. See if we can kind of stumble into the right answer. What happens if I put a 3 and a 3? The carbons are equal, 3 carbons, 3 carbons. The oxygens are these 3 and these 3, which is 6. And this side is 3 times 2. That is 6. So I've got the carbons and the oxygens equal. Now I just need to put a 2 here and fix the iron. Number 11 is straightforward. I'm skipping that one. Okay. Number 12. Number 12, polyatomic ion. Polyatomic ion. Here's a polyatomic ion. So what we have here is my common hint with water. with water. I suggest you write it as H, parentheses, OH, so that you can see hydroxide, the polyatomic ion. Now that we've got hydroxide instead of H2O, it's a bit easier to balance. So let's take a second to figure out what is missing in this blank. If you said 5, you're wrong. Common mistake. This is multiplying. This is 2 times 3 there, okay? It's 2 times 3, which is 6. You put a 6 in there, and that fixes the hydrogen, and then it also fixes this hydroxide in the other compound. Alright, number 13 is pretty straightforward again. We have this hydrogen hydroxide, also known as water over here. Once we throw the 3 in, that fixes the hydrogen and the hydroxide. So number 14, like I said earlier, is one of the hardest ones on here. It's actually number 5. If you go back and look at number 5, they are identical questions. There we go. Balanced a lot easier after you balanced it the first time. And then number 15, we do have a polyatomic ion. What is the name of this polyatomic ion? NH4. Because NH4 also is appearing here. It is ammonium. Once we've identified that polyatomic ion, it becomes a lot easier to balance the reaction and make sure everything's equal. So that is 2 Fe's. On the other side, it was Fe2. So those are equal. And then the bromines here are 3 times 2, 6. This is 6 times 1, which is 6. This is 3 sulfurs, and that's 3 sulfurs. Yeah, everything's balanced there. Then we move on to the stuff that's more nomenclature-ish. Yes, there's going to be 2 questions about nomenclature on here, where you have to first write the correct formulas and then balance it. Remember to use the charges from the periodic table before you balance them. Same thing on number 19. Number 19 we do have, and number 20 we have oxygen. We had 7 elements. BRINCLHOF. These 7 elements don't ever exist by themselves. Brinkelhoff. Anytime you have one of these elements alone, they automatically pair up with their identical twin. So in number 20, where it says burns in air, or number 19, burns in pure oxygen, the oxygen has to be O2. And your worksheet has a couple more questions about writing sentences, but we're not doing that. So, handle your nomenclature as best you can, and afterwards balance it. I do have one huge suggestion, though. If you're struggling with the nomenclature, just do the best you can on the nomenclature, and then try to balance what you have. I can give partial credit if the work is halfway done correctly, but I can't give you any credit if you just leave it blank. Same thing's true on this balancing. If you're running out of time, don't come in just, hey, I just decided to do nothing. I can't give anyone any credit for number 14. It's all blank. But if it had even a couple of things, like, oh, that's a 4, that's a 1, and that's a 2, that's not right. But at least I can kind of figure out what you were doing and give you some partial credit. Okay? Alright guys, clear off your desks. You are going to need a periodic table. We, of course, have several on the front desk. It's time to get our quiz test on. Alright, good luck.